Hey guys, hey, how you doing? Welcome back. Welcome back to the latest installment of Learning Algebra with Mr. Bauman from Mr. Bauman's Basement. Coming right back at you. Same subject, same basement. A little bit different look I got going here. I'm getting geared up for summer. Got the old pool hat, the sun hat, the beach hat. Keep the sun off my face. Found another tropical shirt. The only thing I'm missing is, some sunscreen. Number two, a pool. Don't have that. And number three, we need the sun. Gosh, it's been really pretty cloudy and kind of gloomy the last couple days. But going to try to brighten up your day here today with some good old-fashioned algebra. So, what will you need today? You're going to need your notebook, a pencil, probably not a calculator. Probably not a calculator, but we are, oh my good gravy. Oh my good golly, we are almost there. We are almost there. You guys have run this race. It's been kind of a marathon, right? Especially this last leg of the race. It's been a little bit more challenging for all of us, myself included, but you guys have done an amazing job. My hat's off to you, and keep up the good work. We are almost there. Gosh, we got just next week. That's it. Next week. Good news for you. Today is the last official new material lesson. Last official algebra lesson is today. Next week we're going to do things a little bit different. We're still going to have a video. It's not real algebra heavy, and I'll explain that in the next video. More details to follow. But we're going to also try to connect, maybe via Zoom, some sort of video call, just to connect one last time. But I really appreciate you watching these YouTube videos. I hope, and after looking at your assignments, I'm confident that you guys now know more algebra today than you did when the quarantine and the school closing started like 7 weeks ago. So seriously, hats off to you. Amazing job. Thumbs up, 2 thumbs up, the whole 9 yards. Keep it up. This is your last official assignment. You guys have a really strong algebra foundation. Really strong, and that's just not from this year. That's dating back to all the way back to kindergarten, believe it or not. You started developing these math skills, these pre-algebra skills, the rules of math to lead to this point. You've finished your official algebra course, and your foundation is like rock solid. So I'm excited to watch you guys build upon that foundation through high school and hopefully into college. Continue to take some math in college. You guys are rock solid. Keep it up. I really, really appreciate it. Last section, section 11.2. I got my whiteboard, as always. Got the old marker. I got the magical eraser. And as always, last algebra lesson. Got to hit the old cup of joe. Fairly cold here today. That's okay. It's still tastes good. Good way to start an algebra lesson. Let's get started. I'm ready to rock and roll. I cannot believe this is our last lesson. We started, 2 years ago? And we finally, we can see the finish line. We can see the finish line. We've run this marathon, but we're ready to run through the tape, so to speak. 11.2, multiplying and dividing rational expressions. Gosh, that's a mouthful. Let me move this camera a little bit. Sorry. Our objective for today, we're going to be able to multiply and divide rational expressions, and the key to this today is going to be factoring. Factoring out a GCF, which you guys have done a bazillion times, factoring trinomials, which you've done about a million times, and that's going to allow you to move through these products and quotients, I think, relatively quickly and relatively efficiently. And again, this is our official last lesson. Please don't throw away your notebook. Don't toss it in the bonfire in a couple weeks when you guys are roasting marshmallows. It's not kindling for the fire. Please save it for freshman year. You guys are going to be, whether you're taking Algebra 1 or Algebra 2, you're going to be looking at the same material. It's just another tool in the tool chest. So make sure you hold on to your notes at least through your first and second year of algebra in high school. I think it'll be a good resource for you. All right, so that's the goal here today. I'm going to piece all of this together, all these pieces to this puzzle that we've been looking at. And one of the things I want to review just real quickly, and you actually started learning this back in like 5th and 6th grade, how to multiply fractions. We're not going to look at like just 1/2 times 3/4. That's too easy. But it's the same type of skills, those same fundamental rules of math that are going to allow you to move through the multiplication and division today. Just to remind you, when you multiply fractions, you don't need a common denominator. That's only if you're adding or subtracting. If you're multiplying, you just multiply straight across the tops of the numerators, multiply straight across the denominators. So the first one I want to look at is a product. We're going to be multiplying. Give you a chance to pause the video and get these directions down. Calculate the product. And just for these first couple problems, I do want to review from last video what it means to be an excluded value. Go ahead and pause the video, get the directions, and then I'll give you a chance to write down the actual expression that we're going to multiply. 5 over, I'm reading backwards here, b to the 5th times -3 over b to the 4th. Again, we don't need a common denominator. Obviously, these two denominators, they're not the same, and that's okay because we're not adding or subtracting, we're multiplying. So the same rules you learned back in like 5th or 6th grade when you start first learning about multiplying fractions, those are still the same. Multiply straight across the tops, straight across the numerators, and then straight across the denominators. But you can see why this is becoming more of an algebra problem and not a 5th grade math problem. 5th grade, you didn't know how to multiply b to the 5th times b to the 4th. That just wasn't in your wheelhouse. But now you do. You know the rules of exponents. So if I go to multiply straight across the numerators, obviously I got a positive times a negative. That product is going to be negative 15 over, now let's multiply using the rules of exponents, b to the 5th times b to the 4th. That's right, if you multiply two powers with the same base, add the exponent. So this would be b to the 9th. And that is as far as you can go. That's the simplified expression. We would consider this the product of these two expressions, these two rational expressions. But in the last video we talked about excluded values. When would this be false? When would this not work? That's right, there's only one excluded value. The only time that this would be undefined is if b was 0. So we would say when b is not 0. I don't think on your Google Doc tonight, last official algebra assignment, I should say, I do ask you to find the products or the quotients. But I don't think in tonight's Google Doc I'm asking you to do the excluded values. I just wanted to review it here real quick, knowing that you probably will see it again next year in high school. All right. As always, if you do have questions, shoot me an email. I'd love to help you out. But as always, most of the problems tonight or today in the Google Doc are very similar to the problems we're doing here on this video. So if you need to replay the video and look at some more examples or just look through your notes, hopefully you're taking good notes, you can use that to assist you as well. All right, next example. Calculate, again, same directions. Calculate the product and what are any possible excluded values. Pause the video if you need to, get these directions. We're going to start to incorporate some binomials in this one, and then in just a few minutes we're going to start looking at some trinomials as well. All right, here we go. Our first rational expression, the quantity x minus 9 over x, that's how you would say that. It's technically a quotient, but we're multiplying this rational expression times this rational expression, the quantity x minus 4 over the quantity x plus 7. all we're doing is multiplying, one of the first things you should try to look for is anything that cancels. It's very similar to if I had, if you're back in like 5th or 6th grade and your teacher gave you this problem, one of the first things you look for, do any of these moving vertically or diagonally, do any of them have any common factors? And the answer to this would be, yeah, they do. 6 and 3 have a common factor. So does 7 and 14. So you can do some simplifying first by finding that common factor. That's like 5th and 6th grade. The only difference now is instead of just numbers, instead of constants, we now have polynomials. So now you can start to see the bridge between 5th and 6th grade, 7th and 8th grade. Do these have any common factors? This particular problem, the answer is no. These don't have any common factors. So you can just simply multiply straight across. This would be the product x minus 9 times x minus 4 on the top. Could you FOIL this out? Certainly. I would prefer you leave it in factored form. This is completely factored. Your teacher next year, whoever that might be, will probably also ask you to leave your products, your simplified expressions, in factored form. This is factored. You could certainly FOIL it if you wanted to, but it wouldn't be completely factored. And then you can multiply the denominators together. Again, we don't need a common denominator. Just multiply them together. This would be x times the quantity x plus 7. Again, you could distribute this x here, distribute the x here, but it wouldn't be factored anymore. So make sure you leave it completely factored. So that would be the product. It's kind of a longer looking product, and that's okay. It doesn't make it wrong. But what are the excluded values? What numbers can I not have here and not have here? In other words, I don't want these to become undefined. What would make them undefined? For this one, it would just be the number 0. Kind of like the previous example. So x can't be 0. What else can x not be? In other words, what x would make this number 0? That's right, it's negative 7. If I put negative 7 here and I add 7, I get 0. And if 0 is on the bottom of this fraction, it's undefined. It gets tossed out the window, it's not going to work out. So we would say x can also not be negative 7. So this is about what I'd be looking for tonight, except I don't think I'm asking you to do the excluded values. You're welcome. All right, I'm moving kind of fast. I know some of these videos get a little lengthy, so I'm moving a little bit faster here today. Drop my eraser. All right, let's get into some that are a little bit more complex, because I think we're ready for that. Same directions. I'm just going to start abbreviating. Just calculate the product. Calculate the product. All right, let's look at one that's a little bit more complex. Let's do the quantity of x plus 5 over the quantity 7x minus 21. That's our first rational expression. We're going to be multiplying. It's kind of implied, because I'm using the word product, that I'm going to be multiplying. Let's multiply it by 14x over, now let's look at a trinomial. Let's do x squared plus 3x minus 10. You can pause the video if you need to. If you're kind of like a step writer, it might be helpful to write this down. Step 1, factor if possible. Factor if possible. Can this binomial be factored? Nope. Can this binomial be factored? Yeah, absolutely it can be, because it has a GCF. That's right. Factor out the GCF. Can this monomial be factored? No. But can this trinomial be factored? Probably yes. We're going to try to do that. So step 1, factor first. I know some of you are sitting there thinking, gosh, I do like when you kind of give us like an algorithm to follow, like a list of steps to do. Step 1, factor first. Okay, so let's do that. Let's practice what we preach here. Let's factor. I can't do the top one, but I can factor out a 7 out of that bottom binomial. So I kept the top binomial the same. I factored a 7 out of here, so it's 7 times the quantity, x minus 3. Now let's clean this one up. I can't do anything with the 14x. That just stays on the bottom, or excuse me, stays on the top. But this trinomial can be factored. It's kind of what we did in the last video. It's what we've been doing since like January. Find those two magic numbers that multiply together to give negative 10, add together to give positive 3. Do you get them yet? That's right. It's negative 2, positive 5. Multiplied together, they give negative 10. Added together, they give positive 3. So step 1, factor if possible. I factored this, and I factored this. Step 2, cancel any factors if possible. Cancel factors if possible. So if you're the step writer, and I know some of you are, step 2, cancel factors if possible. Just like you did in like 5th or 6th grade with those two fractions I showed you just a minute ago. Same is true now, except now they're binomials, monomials. What factors here? Anything? You better believe it. Good golly. X plus 5, those cancel. All we're doing is multiplying here, so factors can cancel each other out. What else cancels? That's right, the 14 and the 7 cancel. The 14 and the 7 cancel. 7 becomes a 1. 14 becomes 2. You learned that back in like 5th grade. And I'm looking, I don't think anything else cancels, so now I just multiply straight across the top. 2 times x, that's 2x. And then multiply straight across the bottom. Don't FOIL, leave it factored. This would be the quantity x minus 3 times the quantity x minus 2. So there would be your final answer. Again, don't FOIL this. Leave it factored. So if you're a step writer, step 3, I really didn't write it here. I'm kind of running out of room. Step 3, let me get a different board. Running out of space. So step 3, multiply the tops. The numerators, you guys know what I mean. Multiply the bottoms, or the denominators. They would be step 3. You're going to see a couple of these tonight on the Google Doc. All right, we're almost there. We're getting real close. All right, let's keep plugging away here. Keep racing down the track. See, again, we can see the finish line. People are cheering as they're almost there. Same directions, calculate the product. We're on example 4 here. This one I threw in, and again, you'll see one like similar to this on your Google Doc, so feel free to revisit this video. I threw this one in because it looks a little bit different. I'm not saying it's more difficult, but it just looks a little bit different. Sometimes the looks of something, and this goes for a lot of things in life, if something looks a little strange, people just automatically like dismiss it as like really difficult, or it's so awkward it can't be solved. Just because it looks weird doesn't make it bad, right? It's kind of like some foods. Some foods just don't look appetizing, but they actually turn out to be really good. And this is kind of the same thing. This looks a little weird, but that doesn't make it wrong or difficult. This trinomial, is this technically a fraction? Is it technically rational? It is. You could put this, that's a really not straight line, you could put this over what? That's right, it's really over 1. So I could put a 1 right here, and now we're back to where we started. Can this be factored? No. Can this be factored? Yes. I'm trying to read backwards. That's a 6, right? So we can factor the bottom of the first fraction. So it would look like this, factored out the GCF of 3. And now this can be factored. This trinomial can be factored. Find those two magic numbers. Two numbers that multiply together to give -6, add together to give +1. At this point in the year, you should be getting really, really fast at finding those two numbers. What are they? Multiply together to give -6, add together to give 1. That's right, it's -2 and +3. And that's all over 1. Just like that, we're almost done. So we factored it. Cancel any factors if possible. Oh my stars, it looks like that m-2 and m-2 cancel. Good gravy. And I think that's it. I cannot cancel this 2m plus 5 with the 3, nor can I cancel the 3 with this binomial either. So my final answer, I need bigger boards is what I need, just in time for the last lesson. The final answer would be 2m plus 5 times the quantity m plus 3 all over 3. All right, at this point, I'm hoping you're feeling really pretty comfortable with finding products. You can see that the rules that you learned back in like 5th and 6th grade, just multiplying straight across the top, multiplying straight across the bottom, those still are true. But factor first, then cancel factors if you can, then multiply straight across the top and straight across the bottom. Now, you might be wondering, is that it? That can't be it. And you're right, that's not it. We haven't looked at dividing yet. That's where we're going right now. You guys pick up drinking coffee over quarantine? If you don't, at some point in your life you probably will, and you'll discover that having a variety of mugs really makes the coffee experience all that much better. Whether it's cold or warm coffee, the mug, it's kind of like a hamburger. Like the toppings, to me, like the toppings make the burger. Sure, the bun can be good, the burger can be good, but it's the toppings that really makes a burger. The mug you drink out of really makes the coffee. So, good life lesson for you. But let's look at, speaking of another good life lesson, let's start dividing rational expressions. How about that? Let's change the directions just a little bit. Instead of calculate the product, we're going to calculate the quotient. Calculate the quotient. So let me throw a little bit of a curve at you. Let's do 4k plus 12 all over 6k divided by, and we're going to use like the old school division symbol, quantity k plus 3 over 12k. Ooh, good gravy. If I had shown you this at the beginning of the year, you might have like tossed your pencils up in the air, cracked your calculator over your knee, and then just walked out, because this might have thrown you. Maybe not. Maybe some of you would have stuck around if I had shown this at the beginning of the year. But this is why we see this at the end of the year, because at the beginning of the year, you didn't know what this was. This is a binomial. You didn't know how to factor a binomial, but you do now. Back in like probably 5th grade, pretty sure it is 5th grade, when you have a fraction, let's say I had like 1/2 divided by 5/4. In like 5th grade, you learn that to divide these two, you keep this one the same, change this to multiplication, and then do what to this fraction? That's right, you flip it. In 7th grade, we called it reciprocate, right? So you keep, change, flip. Remember those 3 words? Keep, change, flip. Guess what? you still use keep, change, flip in algebra. The only difference is instead of numbers like this, now you have polynomials like this. Definitely going to see this in high school. That's why I was really trying to do everything I could to get to chapter 11. I want you to at least be familiar with this before you walk into high school in just a few short months. Oops, I just erased my problem. Give me a second while I rewrite this. Getting so excited about rational expressions. I just erased it. 4k plus 12. Sorry. Just got to stare at my beach hat for a second. All right, let's keep the first fraction the same. So I'm not going to touch this one. We're going to keep it 4k plus 12. Whoop, but I just realized we forgot to factor, right? This has a GCF. What can I factor out? That's right, we can factor out a 4. So let's go ahead and do that. So this first one would be 4 times the quantity k plus 3 over 6k. So I didn't flip this one, I kept it the same. The only thing I did was factored out this GCF. On your Google Doc tonight, on your Google Doc, I even gave you some hints. You're welcome. And one of the hints that I give you is to always factor out a GCF if possible. And in this case, we could. So we kept this one, changed this to multiplication, and then flip this one. So this is going to be 12k up at the top and the quantity k plus 3 at the bottom. Keep, change, flip. Now we're back to where we were just like 5 minutes ago. Cancel any factors that are common. So we would cancel this and this. Those guys are gone. What else can we cancel? Looks like we can cancel the k's. There's a k on the top and a k on the bottom. See you later. They cancel. What else? Looks like the 6 and the 12. The 6 becomes a 1. The 12 becomes a 2. So I canceled the 6, became a 1. The 12 became a 2 because 6 goes into 12 twice. 6 goes into 6 once. And oh my stars, we got rid of everything except 4 times 2. Isn't that crazy? Math is amazing. I love math. I really do. I hope you at least like it. But all of this up here, some people would say this mess, all of this is really just equal to the number 8. Isn't that's just, my socks just fell off. And that completely just knocked my socks off. And I think that's amazing. So, enjoy it tonight. Enjoy it. It's, again, last one, so you might as well enjoy it, right? All right, we're down to the last 2. We're almost there. We've run the good race, fought the good fight. Same directions as the last one. Calculate the quotient. All right, let's do this. A little bit of a knuckle curve here. Not just a curved ball, but a knuckle as well. See what you guys are able to do here. My apologies. There's just a lot in this problem. Good things come to those who wait, right? Look at that. That is amazing. We got a binomial here with, oh my gosh, both of these are perfect squares. How about that? We got a binomial down here, and they have a GCF. This guy, he's just sailing his own ship here. There's not much you can do with the x minus 5, but look at this trinomial. That sucker can be factored as well. We got a lot to do here, and we're dividing, which means which one is going to flip. That's right. This rational expression is going to become reciprocated. Keep, change, flip. I even reminded you that on the Google Doc. Factor first. Factor first. Two F's there. Factor first, then start canceling things out. Then multiply straight across the top, straight across the bottom. Follow your steps, those 3 steps that I gave you at the beginning of this lesson. All right, let's go ahead and factor first. Because this first binomial is a difference of squares, this is what we did back in January. What would the 2 binomials be? That's right, x plus 5 times the quantity x minus 5. Because they're both perfect squares and you're subtracting them. On the bottom, what can you do? You got it. Factor out the GCF, which is 4. That's right, it's 4. So this would be 4 times the quantity x plus 7. We are rocking and rolling. My favorite type of music, rock and roll. Kept it. It looks different. Retained its value, right? It's kind of like the wedding cake. How many times have we said wedding cake this year? Cake just sounds good right now. Yeah, red velvet. Oh, I could go for some red velvet cake right now. How about you guys? Favorite cake? Put that at the bottom of your Google Doc. Favorite flavor of cake? Yeah, that's a good one. So we kept this one the same value, different look. So we kept it, change this to multiplication, and now flip this one. So the x minus 5 goes on the bottom. The top of this one is going to be this trinomial, but what do you have to do first? Factor. That's right, factor first. Find those 2 magic numbers. 2 numbers that multiply together to give 14, add together to give 9. You should get it just like that. It's right, it's 2 and 7. So x plus 2, x plus 7. Look at that. That's a good looking board right there. That's an N apostrophe. Good looking. Dropping G's all over the place. Once we've factored it, keep, change, flip. Now you just start canceling factors that they have in common. So it looks like x minus 5, you're gone. X plus 7, you're gone. And we end up with, keep it factored. Again, don't FOIL it. We end up with x, the quantity, x plus 5, times the quantity x plus 2. I just wrote on myself all over 4. That's, congratulations. You guys have come so far. You've come so far, and I'm so appreciative and proud of all the efforts that you've given so far this year. And I'm still in disbelief. This is the last math lesson. It's crazy. Check out your notebook. Look how many pages you filled in your notebook. Some of you, I think, are on your 2nd notebook probably. Again, don't throw them away. Don't toss them in the bonfire. Whew. Anybody else sweating? This, ladies and gentlemen, is the last official algebra problem of the year. I'm waiting for like the confetti cannon to go off. This is the last official algebra problem of 8th grade. Congratulations. I feel like there should be fireworks and balloons being set off right now. But I don't have either one. But we're going to have fun doing this one. Gosh, we're on example 7. Lucky 7. Lucky 7. It's a good number. Not my favorite number, but it's a good number nonetheless. Different directions on this one too. I'm going to throw what's called a complex fraction at you. Let's go. Looks like, sorry about that. Give me one more second here. Oh my. Look at that. Speaking of cake, that kind of looks like a layered cake there. It's not. It's called a complex fraction. Why do we call it a complex fraction? Because it's basically a fraction stacked on top of a fraction. This middle, the very middle fraction bar here is honestly, in reality, this is a giant division symbol, right? So is this one. So is this one. But this one separates this fraction, this rational expression, from this rational expression. So I can rewrite this. This is really 1 over the quantity x minus 2 divided by the quantity x plus 3 over the quantity x squared minus 4. So I didn't do any factoring yet. I didn't do any cancellation. I just literally rewrote this really complex looking thing. It looks messed up, right? It's something you haven't really seen before. It looks kind of weird. This really is this. The very last problem on your Google Doc will look like this. Rewrite it into something that's a little bit more like pleasing to the eye, so to speak. It's a little bit easier to look at this than it is to look at this. Once you have this, factor first, right? Factor first, really the only thing that does factor is the second denominator right here. Why does that factor? Because it's a difference, because we're subtracting, of 2 what? X squared and 4 are both, 2 words, perfect squares. That's right, they're both perfect squares. So this factors into the quantity x plus 2 times the quantity x minus 2. I haven't done the famous 3 words, keep, change, flip, but I'm so close to the answer, the quotient. You can smell it. Oh, it smells good. Are we ready? All right, so I factored first. Now we're ready to keep, change, flip. I need some space on this other board. So let's keep the first one. Change it to multiplication. And now let's flip the other one. The other rational expression. So it's x plus 2 times the quantity x minus 2 all over the quantity x plus 3. Once you factored it, once you did keep, change, flip, start canceling things if you can. Looks like the only things that cancel here is the x minus 2's. Here and here. Those guys are gone. So we end up with the quantity x plus 2 over the quantity x plus 3. Ladies and gentlemen, that is the final page of your notebook, at least for algebra. I'm going to ask you to do one short little assignment next week. It has nothing to do with algebra, but there will be one more like assignment, but this is the official last algebra problem for 8th grade. So my hat's off to you. Seriously, I really appreciate all you guys' efforts and all the time, questions, responses, participation, energy, you name it. Really appreciative of it, especially these last 7 weeks. It has not been ideal. I know it. I miss you guys. I wish I was there in the classroom teaching like we normally do, cracking jokes, at least what I think are jokes. Sometimes you guys don't laugh, and that's okay. But I really do miss you guys. I hope you and your family are doing really well and enjoying the time that you have at home, and going to enjoy a fantastic summer. And hopefully we'll be able to see each other soon. But until then, be well, be safe. If you have questions on the Google Doc, shoot me an email. But otherwise, hopefully, I'll see you guys on a Zoom call or some sort of video call next week, and we'll be able to share a little bit. So hopefully I'll see you next week, probably on a screen, but I'm looking forward to that. Be kind to one another, as always. Be kind to one another, especially your family. Be patient with one another, especially your family. And above all, please continue to pray. We need lots of prayers being sent up to God, that He continue to look over us, guide us, protect us, keep your family safe, keep your classmates, our world. It needs a lot of healing right now. So continue to pray, and have a wonderful day and a fantastic weekend. And don't forget, Sunday's Mother's Day. Big shout out to all those moms out there. Wish your mom, grandma, a very happy Mother's Day. Have a great day, guys.